All right, Libby, it's good to hear from you. I'm going to do a quick video on function notation to try to help clarify. I am going to talk fast because then it would just be easier for me to send. And you can always pause it and replay it. So, function notation is the idea of basically naming functions. So a lot of times they look like this, and how you would say it, this is function f. So the name of the function is f with the value x plugged into it. F of 3, function f with the value of 3 plugged in. And when I say plugged in, I mean we're plugging that number into an equation, and we'll see that with these examples. F parenthesis f of x, this is the function f with the value f of x, so with the function actually plugged in. So one thing that's nice is we can actually plug functions into other functions with this. So here are two functions, f and g. This is what they would be when the value is x. So f of x is 3x minus 1, g of x is negative 2x plus 6. What is it when we get these values? So f of 4 is saying take function f and replace 4 into the function. So now where I see that x, I'm going to replace it with a 4. 12 minus 1 is 11. G of 2, I'm going to take this function g, but I'm going to replace, since I'm replacing what's in the parentheses with the 2, where that is, I'm going to replace that with a 2 plus 6. Negative 4 plus 6 is 2. So all it is, it's a shorter way to say I want to plug different things in. So f of negative 1, 3 times negative 1 minus 1, negative 3, negative 1, negative 4. Negative 2, g of 0 is negative 2 times 0 plus 6, which is just 6. This is where it gets a little tricky. This is the case where we want to actually take function g, so this entire thing, and plug it in to this space. So it's 3 parenthesis. I'm replacing the x with now this entire function. Negative 2x plus 6. And then I have the minus 1. So again, we just replace the x with the whole other function. Now, I can't actually solve this. All I can do is clean it up because, again, we don't know what x is. So to clean it up, I'm going to distribute. And then we have the minus 1, negative 6x plus 17. So that would be the cleaned up version of that. And that's all you can do. Okay, the other thing with function notation is sometimes they give you a graph. So I'm calling this graph h of x. Okay, it's not linear, it's just a random bunch of lines. They might say, what is h of 2? So how do we use the graph? Well, what they're saying is the x value is 2. What's the y value? So I find an x value of 2. I go down to the graph. The y value is negative 7. That's the point. So h of 2 is negative 7. H of negative 6. The x value is negative 6. What's the y value? 2. So h of negative 6 is 2. These are essentially ordered pairs. 2 comma negative 7, negative 6 comma 2. Those would be ordered pairs. The final thing is working backwards. Is they might say h of x is negative 8. So they're saying the y value is negative 8. So you find the y value of negative 8. Go over to where the graph is. Go up to your x value. So x equals 5. So again, the ordered pair would be 5, negative 8. H of x is 9. So what x value gives me a y value of 9? Find the y value of 9. Go over to your graph. Go down. My x value is 14. X equals 14. So 14 comma 9. Where you have to be a little careful is if they said h of x equals 0, let's say, or negative 1. H of x is negative 1. Well, that means there's two options. So you got to be a little careful with those. But yeah, that's function notation. Hopefully this helps a little bit. Again, let me know if you still have questions.